Today we are going to connect the light dimmer using the following component and tools. First of all, we need light emitting diode, which has two terminals, positive and negative, anode and cathode. The anode terminal is the terminal that it has the smallest smallest conductor inside the plastic container. If you look inside the plastic container, there will be two parts, small and big part. The small part is the anode, the positive. The second one, or the larger one, is the cathode, the negative terminal. We need also a fixed resistor, which is about 100 ohm. We need a trimmer or a variable resistor, which is a resistor that could be used as a potentiometer, and its value could be changed. It has three terminals, middle and two sides. We need soldering wire, cutter, connection wires, battery, vidio board, which is a board that it has two sides, one side covered with metal and the other side is plastic side. Components could be fit on the plastic side and soldered from at the back of that side. Lastly, we need a hot iron to connect the components. First of all, we'll start from the lid. We'll connect the lid in one of the lines in the board, vidio board. Each row here is connected together and it has too many holes, so we can connect the LED between two lines. Never do the connection with two terminals of the LED in one line, because that will short circuit the terminals. So first of all, we'll connect the positive terminal upward and the negative terminal downward, like this. And it looks from the back like this. We'll push some and we'll bend the terminals of the LED to prevent it from falling down. Then we'll connect the fixed resistor from the third line to any place in the vidio board. Again, we can't connect the fixed resistor between two holes in the same line, because that will short circuit the resistor and it will look like this from the back. Again, we need to bend the resistor to prevent it from falling down. Lastly, we connect the potentiometer and we make sure that the middle terminal is not connected to anything. So we'll put one of the sides in one hole and the other two sides will take places like this. This side is bent a little bit. We'll use the tool to align it. Then we'll put it in its place. Okay? Now the variable resistor is connected, and these are the terminals for the variable resistors, 3 terminals. Now we will make the soldering. The soldering techniques should start from the hot gun itself. You have to test the hot gun. If you can feel the heat comes out from the hot gun, that means it's ready. Then you'll connect the hot gun to the terminal. Like this. Put the hot gun on the terminal. Put some wires. When the wire melts, remove the soldering wire and then remove the hot gun. Don't remove the hot gun before you remove the wire. Now, after connecting the battery, you will find that the light is on, the LED is on. To change the light intensity, we change the variable resistor, and you can see I can easily change the intensity. This is minimum intensity, the zero intensity, minimum, maximum intensity. Now, what happens actually here that the potentiometer controls the current flow inside the LED. When the current is higher, the LED is fully energized. When the current is lower, the LED is less luminous. Now, to add more fun to our circuit, we can easily connect a capacitor that it is 1000 microfarad, and it is polarized capacitor. It has negative terminal, where are the strips there, and the other positive terminal, there is no writing here, no any description of the polarity of that pin. So this pin is the positive and the second pin is the negative. I'll connect this capacitor parallel to the LED, positive to the anode, negative to the cathode. The function of this capacitor is to delay the switching off procedure. Then the light will keep on for a while. And this is what exactly happened when you switch off any electrical device that it contains light indicator. Which is due to the time constant of that light. You can see here the light is fully working. I remove the battery, or I disconnect the battery, the light goes off and it takes a few milliseconds to turn off. You see, it's going off very smoothly, not instantly like before. This is because of the capacitor. Of course, the greater the capacitance value, the greater the time required to turn off. And you can easily notice that. This circuit is called an RC circuit, and the capacitor is discharging through the internal resistance of the LED. If I add a series resistance between the capacitor and the LED, time will increase because time constant equals R multiplied by C. R here is the internal resistance of the LED, and C is the capacitance value, which is 1000 microfarad. This is all for today. I wish you have fun and you have learned something behind potentiometer, RC circuits, and the LED control. I wish to see you in other posts. Good luck.